Hello everyone. In this video, I'm going to cover the topic on the fuzzy regression discontinuity. And after covering topic 6, which was about the RCT plus instrumental variable. So after covering this topic in topic 6, then topic 7 would be relatively easy to understand its idea. So it's basically in topic 7, we're going to do the same thing, but we're going to talk about regression, discontinuity, plus the IV. And when we talk about this combination, we usually refer to it as the fuzzy regression discontinuity. So we're going to talk about why we call it fuzzy, when can we use it, and so on. All right. So in the topic when we discussed RD, okay, we discussed that we have something called a threshold level or a forcing variable or a cutoff point, and all what we need to do after we determine a certain cutoff point is to check those who are above and those who are below that forcing variable or threshold. And the big assumption is that those people who are just above and those people who these observations that are just above or these observations that are just below are typically random. Okay, so our analysis is not going to be all the observations. As we said, it's going to be those who are just above and those who are just below. And as we discussed it in the RD, that this methodology would lead to losing so many observations, and this was one of the disadvantage that we discussed in that topic. All right, and we are going to talk about what is the local average treatment effect in that context of the RD, and why it is called the marginal group or the late impact. Okay, so when we discussed the RD, we discussed a very important assumption, which is there is no manipulation of that threshold level. Like, it is chosen at random. There is no manipulation either by, let's say, the staff or teachers or students or whoever to manipulate that threshold. These are just examples of manipulation, which again we discussed it before, and I gave you personally an example, like when a student would come to me and say, oh, can you give me like extra credit because I have to maintain my GPA above 3.5, so I keep my financial aid program. So this is a kind of manipulation by the student, because they are manipulating their GPA in such a way that they can maintain a program. Okay, so if the financial aid program is talking about students who are 3.5 or above, so if we have many of those students who are trying to ask their professors about an extra credit to maintain the 3.5 at the least, then we will find the cluster, so many students are at the 3.5 cutoff. Okay, here are other examples. So if I'm talking about in the medical field, we're talking about babies, and babies would get extra service, okay, if they are under the 1500 grams. Then if there is any kind of manipulation, then I would find that the 1499 grams, we have a cluster of many observations. Okay, and this could be like a reflection of a potential manipulation by the doctors or the nurses or whoever in charge of this program. The same thing if I'm talking about a graded exam, then like grading it harshly or easily is a way of manipulating the number of students passing the exam. All right. So manipulations happens in real life, so it's not uh, like a rare example. No, it happened in many applications, okay, in many examples. So when we talk about the RD, then we need to talk about the threshold level or the forcing variable. And this forcing variable is the one that is going to determine to us who is supposed to be in the treatment and who is not. Okay, passing the threshold is a part of the treatment, not passing is a part of the control, or the opposite is true. So some kind of threshold to divide our observations into two groups. We mentioned that could be some violation where there are some people who are supposed to get the treatment are not getting the treatment, or some people in the control group they manage to be in the treatment group. So that means we are talking about a violation of a very important assumption, which is called the perfect compliance assumption. Okay, so we are assuming that everything is not violated, like we don't have any assumption that is violated, or we are assuming a perfect compliance, a perfect real world. But in reality, it actually happens to be the case that there could be some imperfect compliance or violations, and hence we are not going to expect that the outcome is going to be the correct or the actual outcome that is supposed to be. So if we talk about two options, option one, intend to treat. In this situation, we are assuming that everybody that I'm going to offer the treatment are going to take the treatment. Okay, and if this is the case, then we don't have any problem. I offered the treatment to 10 people and 10 people took the treatment. And then 0 from the control group are getting the treatment. So we have the perfect situation, right? So if we are talking about assignment to a treatment, okay, if I have full compliance to the rule or the threshold level, then we don't have any problem. But it could be the case that the assignment to a treatment is not the same as the actual treatment, okay, for so many reasons that we discussed in terms of the violation of the assumption, whether imperfect compliance or some kind of manipulation and so on. So in that situation, as we discussed with the previous topic when we had this combination of RCT and IV, it's the same thing. If I had a certain threshold, and for some reason people who are supposed to be above the threshold happens to be below the threshold, or the opposite is true. So in this situation, we have to use the instrumental variable. So the instrumental variable combined with regression discontinuity is used in order to overcome a situation where we have imperfect compliance or a violation of the perfect compliance. We call it fuzzy because we are just talking about something that is not sharp, okay? So it refers to a certain situation where we are talking about a treatment that is not perfectly binary. We're not going to see 0 and 1 in our Excel sheet. So we are, or our Excel column that represents the treatment. So it's not going to be 0 and 1, but it's going to be fuzzy, which means that could be, for example, 0.8, 0.9, something like that. In the sharp regression discontinuity case, we are talking about a clear division. I know that those people who are above and those who are people that are below a certain threshold, but this clear division is based on a certain assumption that I have full compliance, no problem. So in this fuzzy regression discontinuity, we are just saying that this strict division between the people is not clear, okay? So it happens because of manipulation, or it happens because some people above the threshold happens to be below, or the opposite is true. Okay, so when we talk about fuzziness in real world complexities, it's basically, as we said, some people decided not to comply. I assigned them to the treatment, they did not comply, or I assigned them to the control and they actually managed to get the treatment. In between brackets, you have these examples. Okay, so fuzzy because it captures the uncertainty and the variation. It shows us some examples of real situation, more complex, because we are not going to have like just everybody who signed up for the treatment is going to be taking it, or the opposite is true. So we have some kind of violation, and in this situation we have to use more advanced econometric techniques, which is the instrumental variable. So when we look at the assignment rule, we need to have a forcing variable, right? And this forcing variable is the one that is going to divide our observations between left and right, or part of the treatment, part of the control. And we are going to assume that this threshold acts as our random component, assuming, which is this big assumption, that there is no manipulation of this threshold, the choice of this threshold is completely random, and so on. So we are going to assume that this variation in the treatment, due to the rule, which is random, which is the forcing variable, was going to help us to explain the outcome, whether the outcome is academic performance, test score, or any other outcome variable. So in our previous combination, which is the IV with the RCT, which is our previous topic, we were assuming that there is a distinction between an offer of treatment and the actual treatment. So you might offer 200, but those who are actually part of the treatment are 70, right? So we need to differentiate between two important terminologies, which is the intent to treat, whom you actually intended to treat, right? And those who actually took the treatment. So the intent to treat, we call it the reduced form. It's the impact of the instrument on the outcome. So if my outcome is Y and my instrument is Z, then the reduced form is how Y can be a function of Z, how Y can be a function of the instrument. But however, we know that this impact is not direct. This impact comes through the impact of the instrument on the endogenous variable or the problematic variable. So we will need to have a first stage regression in which we have the impact of Z on the treatment participation. So we're gonna say if this participation, we call it D, then I want to know what is the impact of Z, which is my instrument, on the participation, right? And I'm assuming that this participation is going to lead to an impact on the outcome, right? So that's why when we say a reduced form, I'm like writing Y is a function of D, but D is a function of Z, which implies that Y is a function of Z. Okay? So it's like Y depends on D, but D depends on Z, then Z affects Y. So this is called the reduced form, and the reduced form would depend on the first stage regression. Okay? So in order to analyze the impact of a certain program, I need to focus on those who actually complied. And when we say complied, number one, those who were offered the treatment and they accepted the treatment, this is number one. And number two, those are the same people who I offered the control and they did not accept. So by the end, I need to find this impact, which is what is the change in my outcome because of the change in participation. But actually participation is endogenous, right? And if participation is endogenous, then I would need to instrument it, which is the first stage regression. So it's like talking about what is the impact of the instrument in the first stage regression. Okay, so you're talking about what is the reduced form impact because of the first stage regression. Okay, so it's exactly the same what we did with the previous topic with RCT. Like there is nothing new. The only new thing is how we are going to create our treatment versus our control group. And in this topic, or in this particular topic, we are talking about dividing based on a certain threshold. So again, um, intent to treat, it's the impact of the assignment to treatment on the outcome, difference between those who are above, those who are below, in terms of difference in scores, which is our Y. And then the first stage regression is going to be the difference in participation rate, which is D, those who are above the threshold and those who are below the threshold. Okay, so we can actually create this late impact, right? The late impact is equal to this difference in scores, which is the reduced form or intent to treat, right? Number 1. So this is 1 divided by 2. So the difference in participation rate, which is the first stage. Nothing new, just like we are talking about the same that we did before, but just we are talking about a different way of reading our groups. Same assumptions must hold. Again, in order to use IV, I need to have important assumptions satisfied. The number 1 assumption is that this instrument affects the receipt of the treatment. So being assigned to the treatment by the RD rule increases your participation in the treatment. So it's like this: my participation strongly correlated with the instrument. Okay, the higher the chance of being randomly selected in the treatment, the higher the chance of participating in the treatment. Okay, so this is all about the first stage assumption. Like here, this is the first stage assumption. We are talking about assignment and participation. I need to have strong relationship, statistically significant relationship between these two. In more advanced econometric course, we would be actually testing using first stage test, second stage test, and so on. The second assumption is the exclusion restriction, which is the instrument affects the outcome only through the treatment. So it's like this: Y affects Z. We know that. Z affects Y, where Z is the IV. But we also know that this relationship is not direct. This relationship is because Y depends on participation. Participation depends on being randomly assigned. So this affects D. D affects Y. Hence, we can say that Y affects Z. So it's indirect. So being assigned to the treatment, which is random, does not affect the outcome directly. This X should be on this line, okay? This broken line. So should not affect the outcome directly, but it affects it through 2 steps, 1 and 2. All right? And then the third one is the monotonicity assumption. We are talking about no defiers, those people who would do just the opposite. Why we are assuming this? Because I don't want to assign someone to control and he or she be part of my treatment and hence like affecting the outcome of my results. So those people again do not exist. Again, 3 circles: the Y circle, the Z circle. I'm sorry, not the Z, this is the D circle. Variation in treatment. D circle and the Z circle. And I'm looking at the overlap between the 3 circles, and this one would be like, what is the impact of the instrument on the D, and then how D through the instrument affects Y. So that's why I need this part that overlaps between the 3 circles, and this is just like a figure that helps us to understand, and nothing like important about this figure or these 3 circles, but it's just like, it's nice to have a look to give you like an idea of what we're talking about. But this is more important when we talk about the regression. Again, talking about a regression using all these Greek letters, we are talking about again three important models. The first model is the intent to treat, the reduced form, the connection between my outcome and my instrument. Okay, so this is the assignment. You can actually add, this is the random assignment. We can add the word random here. So this is the random assignment to treatment. Actually, it's not the random, I'm sorry. So this is random when we talk about RCT. So this is like based on the threshold. Okay, so maybe write the threshold assignment, because this is not random as like the RCT is not like we refer to it as a random selection, but it's random based on non-manipulated threshold. Okay, so it's still random, but just to be more specific, we are talking about threshold assignment. All right, so I remember when we were talking about RCT, I added the word random here, but here, yes, random still, but again, threshold, like it's taking its randomness from the threshold number or the selection of the threshold. So again, outcome depends on the instrument, right? How far you are from the cutoff point, and an interaction, because again, this affects the slope of the regression, right? So the first stage regression is how my participation variable is affected by the instrument. Again, the same exogenous variables are here. And then the late regression, again, it's going to be the impact of participation on the outcome, and again, our other two important variables. I want you to notice that here the D is replacing, right, the Z's here. Okay, so this one is telling us that we are not just talking about the impact of the instrument directly on the outcome, but this impact is coming through the D hat, where D hat depends on Z, right? So the outcome that we are getting from here is called the local average treatment effect, or you can call it the two-stage least squares regression. And this is kind of giving us the impact among compliers. Okay, and that's what kind of more accurate output. Or you can actually do it in Stata. We have two options, like IV regress or IV regress 2. So whatever the commands that you have in Stata, I think you would have to, with the current version, you might need to install the IV reg 2. But again, the procedure is similar to what we did with the RCT. And here again, the selection of the bandwidth, so there is nothing new. So when we talk about late, again, the question is why we call it local. It's local actually to those who are around the bandwidth, okay, or near the threshold. We call them compliers because they accepted and participated based on a certain rule, which is the threshold. And this is very important. Remember, those are the characteristics of compliers. It has to satisfy steps or characteristics 1 and 2. They accept and participate, and number 2, they refrain if you assign them to the control group. So let's take this example, and this example is about remedial college courses, and the question is whether being assigned to these courses help students to graduate. Okay, so these are developmental courses that help students to increase their skills and help them to graduate, and then they are often taken during the first years of college. And it is like being selected in these courses depends on a certain cutoff score. And the cutoff score that is used in this particular example is the Texas Academic Skills Program, TASP. And based on this TASP, students are selected in order to be part of the remedial college courses. Okay, so because we can have some manipulation, then we need to be using a fuzzy regression techniques. Okay, so the question is whether being part of here increases academic performance, including graduation rates, whether it increases the chance that students are earning more credits throughout their college years, or whether it's just doing the opposite. So it can have like a positive or it can have a negative impact if it delays the time to get the degree and graduate. So the question is whether it's good or bad, okay? And we create a model, and in that model we are actually trying to find the impact of this remediation based on certain cutoff, which is in this case is the Texas Academic Skills Program. And this is done for two groups of students, those who are in a 2-year college and those who are in a 4 years college. And looking here, we can see a clear cutoff. It's not a clear cutoff, a clear jump around the cutoff. And you can read all the interpretations here. So looking at the probability of students placed in, so we are talking about the probability of students placed in remedial education courses. Those are based on a selection of a certain threshold, which is the TASP scale score. And looking at this threshold, we understand that those students who are scoring above are ready for college. So they don't need to get these courses when they go to college, okay? Because they are relatively, sorry, let me go back here. So those are relatively good students. So whether they need to take these remedial college courses is lower than those who are not performing as well on the TASP. And then those who are below are not considered college ready, so they need the courses to build their skills, whether writing, reading, math. We can see that there is a clear discontinuity at the threshold. We see that there is a jump. We see that the two lines are not the same for those who are in the 2-year versus those who are in the 4-year college. And by reading the ones who are in the 2-year college, we see that those who are just below the passing score, they have a 36% higher probability of being in remediation as compared to those who are in a 4-year college, they have a 42%. Okay, so this discontinuity, which we actually need to see if I'm saying that there is an impact of a certain program, it provides evidence that the score affects the educational trajectories. And when I say trajectories, because it's not only has a jump, but there is also a change in, right? When you check here, there is a jump, but there is also a change in slope, like it's not a straight line. So looking at, yes, we are here. So looking at the model, it's like we have a second stage impact, which is the late impact. And this impact depends on first stage, where the first stage is you have your remedial courses, and this remediation depends on a certain cutoff, right? And this cutoff is the TASP. So the TASP affects the chance of being in remediation courses, and the remediation courses affects academic outcomes, whether like graduation, whether the number of credits that the student is earning, or any other academic outcomes. And according to the results, the estimation results, this is for the 2-year college and this is for the 4-year college. You have so many variables here. The academic credits attempted in the first year, the total credits, transferring up to 4-year from 2-year or down to 2-year from 4-year, college attainment, at least 1 year, 2 year, and all of these are actually relatively insignificant. So you can read all the important results here. The negative significant coefficient of the variable remediation on the number of credits attempted. So this one would tell us that students who undergo remediation would get fewer credits. They don't have time, right? So those who are stuck with these courses, they don't have time to get more credits during college. So when you see number of credit hours, you see it negative significant, whether you're talking about 2 year or 4 year. So the number of credits attempted gets reduced because they don't have time, right, to get more other credits as compared to students who are not taking these remediation courses. But other than that, most of the results are insignificant. Like if you check the table, the coefficient for remediation on the attainment measures, degree completion, graduation rates, right? The earning after they graduate, even the outcomes for the 2-year college, all of these are statistically insignificant. So the impact of these kinds of courses on academic performance or academic outcomes doesn't show any statistical significance. So the only mainly significant thing is showing a negative impact, which is reducing the number of credit hours per student. Also, for external validity of this model, it was compared with so many other papers, and they found that consistent findings. Most of the students who are in remediation, they earn fewer credits, so it's matching what other research papers found. They actually found it has also another negative impact because it decreases the probability of passing courses in subjects where remediation was deemed necessary. So let's say the student needs a remediation course in math. They found out that it decreases the probability of passing the math course. So it's like, why we're taking this remediation courses? Also, it decreases the overall completion, degree completion. It has a bad impact, right? However, because so many educators, they feel the necessity of having these courses, they had suggested that what about we can blend it into the standard coursework. So probably the first 2 chapters or the first 2 topics of a certain math course would have some refreshments about, okay, these are the things that we have taken in high school, and it's just like kind of a solution in between having these remediation courses or not having it at all. So they suggested, okay, how about we just blend it into the courses, whether reading, writing, or math. All right. And one of the examples given is about this implementation in the CUNY, which is the accelerated study in associate program, and this one had all these courses blended into the main courseworks, and this kind of try to help the student to do better or increase their skills in college level courses. All right, so I'm gonna stop here, and this is basically it. So again, as I said, topic 7, it's relatively easy in the sense that we are not like seeing instrumental variables from scratch. We have already seen it. We discussed its assumptions, how we can apply it, first stage, second stage, late effects, and so on. So that's why this one is relatively easier or less challenging to understand. All right, so I'm gonna stop here and let me know if you have any questions.